Okay, so we are live right now. We're going to be covering percentages today, as well as interest. That's going to wrap up the rest of our ratio, proportion, and percentages chapter. Just adjust the camera right here. There we go. I'm just going to wait for people to come online. So just a quick recap. We can go ahead and add all of these different riddle lessons together. You can always go ahead and skip back. I did find out, unfortunately, that during live stream you can't go back, at least from my end. Perhaps from your end it can also go back as well. Oh, hi, we have someone else who has joined the class. So we're just gonna wait at least for one more person to join. So just for attendance purposes, if you're attending the live chat session, go ahead and type on the comment here. That way I can see your account name pop up. If not, just go ahead and just send me like a separate text as well. That can work as well. Just checking if there's anyone else who has sent a message. All right. So we'll just go ahead and wait for another minute, and I'll just go ahead and begin. All right, I'm gonna go ahead and begin. So with percentages, if you see this right here, you're going to be dealing with percentages. This is the percentage symbol. So what does percent mean? Percent really means per centennial. Now, if you're local, you might think centennial as in the restaurant. No, I mean centennial as in per 100. Like if you think of the word century, it means 100 years. Or if you think also how the United States economy is based on the decimal system. So like we use cents, and that means if we add up 100 cents, we get a full dollar. So ta-da! Also, another technicality on verbiage is it can mean per 100, or it also means out of 100. Essentially, they both mean the same, but for some more sense either saying per 100, so there's 1 per 100 of these other items, so that would be 1%, or I can say 1 out of 100. So let me go ahead and erase. So let's say I have $100. And I spend $25. Now, this introduction to percentages. So this becomes the same thing as, or if we go ahead and Now we know that percentages, we always multiply times 100, or we move the decimal point 2 spaces to the right. Let me go ahead and use a different color. So from decimal to percent, move decimal place 2 times to the right. So we do that. Since we're going to be ignoring the 0 now, now that the decimal point is over here, we're going to go ahead and do this. However, it's still not a percent. We still think it's 25. If we do this, we add percent symbol. Now we have our fraction to decimal to percent, and this is how you can convert freely between all of them. Something else I do want to mention is that, as we always do with our fractions, is that we can go ahead and simplify. So 25 out of 100. I know 25 fits 4 times over 100. Oh goodness, that is. Let me draw that nicer. There we go. I know 25 fits in 100 4 times, so that would be the same as 1/4. And a great way if you're trying to save money and track your spending is not just look at how much money you're spending, the actual amount, but if you see how much money you have, you're going to see like, well, $25 might not seem too much of a big deal, and actually might be how much you spend when you go out to eat at a restaurant for 2 people. However, if you say, I just spent 25% of my money, it kind of it begins to hurt your wallet a little more. Even though it's the same amount, we're able to understand it better. So like, now we can see it visually, like if it was a pizza, now we're going to see it as though it's 25%. Like, oh, I'm only left with this much money left. Also, I do want to mention this drawing I just did is not drawn to scale. Clearly, there. Now it's a little more, that's more of an accurate representation. There we go. Any questions so far? All right. So I'm going to go ahead and erase this. Some other terminology we want to get ourselves familiar with. Percentages are the base, the part, and the rate. So with the base, we're talking about the whole amount. In our previous example, that would have been the $100. That's the total amount that we're talking about. Next, we have the part. It's the portion, or part of the base. Truly, another way to remember it, it's really percentage. And then our rate is the number followed by percent symbol. The part of the right, they're very similar. So let me just go ahead and write an example up here. That way we can go ahead and label. So let's say we have a part and we divide by our base. In our previous example, we were talking about money here. We're just going to go ahead and say that we're talking about 20 items in total, but specifically, so it just shows like a higher rate. But typically, if I'm talking about like 20 tomatoes I have in my garden, and I'm saying that 3 have like ants on them, I can't say there's 40 tomatoes because the total that I'm talking about is 20. All right, so next from here, I can just go ahead and simplify. So 3, how many times can it fit into 20? It can fit, it doesn't fit nicely unless I go ahead and start to multiply. Now this is going back to our previous chapter. And we always multiply a fraction by something else that has a total value of 1, we get the same value. So here I'm just going to multiply by 5 on both top and bottom. Remember, top and bottom have to be the same. Otherwise, the value is not the same. Okay, so now we have a base of 100. Yes! This makes your life much easier. If you're dealing with something that can easily be, have the denominator converted into 100, go ahead and do so. It might make life a little easier. So 3 times 5 is 15. All right, this is easy. So what is my part? 15. And don't we know that we can go ahead and get our rate by doing 15. And we want to go ahead and change that into a percentage. So since we're not dealing with a decimal right here, if we can go ahead and write this as a decimal, we can go ahead and move twice over here. 15 is the actual number I'm talking about. And then I go to 15% over here. Any questions? With the part in the base, this is really going to help you just look at a question and see, all right, what's the whole amount that they're talking about? And then what is the part of the base that they want me to deal with? Something that you also want to take into account is that never, ever, ever in a fraction will you see a percentage. You're going to go ahead and have to rewrite it into a decimal. That way it's a lot easier to work with. All right, I'm going to go ahead and erase this part. So let's go ahead and go into a word problem. So normally when you go into a restaurant, there are usually tips involved, like 15% gratuity, or it might go up to a higher amount if your party is more than 6 people per se. So this is where we can see percentages come in handy. And if you're really smart, and especially if you're dealing with cash or a limited amount that you want to use from your budget, you can go ahead and use percentages and pre-calculate your gratuity. That way you know how much is the total amount you want to spend when you go out to dinner. Okay, so let's just say that at restaurant A, Jackie's bill is $20. She tips the waiter I'm not saying that all waiters should be tipped $3. I know that in different states or even different countries have different tipping policies. We're just going to go ahead and say that she tipped the waiter $3 just to make it easier on the problem. So now we're going to be wondering, how much did she tip as in a percentage? So what was the percent that she tipped? Okay, so the total amount of her bill in this case that we're talking about is $20. This is going to be our base, which is the denominator. Now we're going to be talking about the part. So her tip was $3. That's going to be our numerator because this is part of the $20. So then we want to find out what is the percentage that she tipped. So we know that it's the percentage we also know for sure that it's going to be this way, that it's organized, because we're talking of how much she tipped. So the tip part, our focus, is going to be the numerator, which is the $3. So if we go ahead and work with this. So again, we have the part and the base. We're going to go ahead and multiply it by 5 like we did previously. End up with $15 out of $100. So if just for the sake of argument, we're just going to go ahead and get rid of these dollar signs just to make it easier when we're carrying over, and also because it might confuse us later on right here. Because now we're talking about if we're being more theoretical here because we're increasing the numerator and denominator evenly. However, now we're talking about if she spent is $15 out of $100, or she tipped $15 out of $100. So just to make it a lot easier when we're looking back at our problem, we're gonna get rid of the dollar signs. So we see 15 out of 100. We know that this as a decimal is 0.15 because when you divide anything by 100, here's a little tip too. So here are two different instances. Let's say we're divided by 10. We're going to move the decimal place, or the decimal place of this original number. So let's say 15 over 10. It's really going to be 15, and we're going to move the original decimal point 1 time to the left. Move decimal to the left once. However, if we are dividing 15 by 100 like we're doing in this situation, it's the same thing as where the decimal point is here, and we're going to move it twice to the left. So here, move decimal to left twice. Okay. So knowing that background information, we turn the 15 divided by 100 into 0.15. And now we can convert that into percentage by moving this over here twice to the right. That to be 15%. Some of you might wonder, well, we divided by 100 over here, which we move the decimal place twice to the left, but then over here we're doing twice to the right. That worked out perfectly in a way that we could have just carried this 15 over here, but you still got to go do your proper methods of moving your decimal place depending on what step you're in, from converting from like a fraction into a percentage, because not everything is going to be divided by 100 perfectly. You might even get 1,000, so that changes the overall number of decimal places that you're working with. So here in this problem, we know that what was the percent that she tipped? She tipped 15%. It's also in some places in the United States, if you don't tip 15% of your total bill, it's at least 15% of your total bill, it's considered bad taste. So I'm going to go ahead and erase this. there's actually something else that we could do since we're dealing with our percentages. This actually is starting to look like a proportion. So let me go ahead and erase our extra information right here. Oh, hi, I see another student. Okay, so let's undo this and erase that. There we go. So we know that 3 over 20 is a 1 ratio, but we know for sure it's equal to 15 over 100. So by having two different ratios equal to each other, we're going to consider this a proportion. So another way that we know it's indeed 15, or if we didn't know what 15 was, our curly x. With proportions, what do? We cross multiply. So we're going to go ahead and cross multiply. So whenever we cross multiply, we're going to get with 20 times x, which can just be rewritten as 20x, and then 3 times 100 is going to be equal to 3 times 100, which if we simplify becomes 20x is equal to 300. So indeed we know that we are dealing with 15% because if we cross multiply the different proportions, we get that value. Any questions? Any questions? Okay. I know people might be popping in and out throughout the live stream. That's okay. You can go ahead and rewatch this later. And if really you have any questions, because I might have already gone from the foundations and moved on to something else, don't hesitate to ask. That's what our little chat box is there for. So I'm going to go ahead and erase this, and we're going to move on to an entirely different problem. Oh, no questions. Okay. Okay, so next we're going to be doing a problem that says at a factory, that makes light bulbs. They anticipate 2% of all light bulbs that's light bulbs manufactured that day to be defective. If 900 light bulbs were made in total, yesterday, how many of those light bulbs would you expect to be defective? So we're talking about they make 900 light bulbs in total. We expect 2% of those to be defective, and they want to know what is the actual number of defective light bulbs. So with our word problems, we have a lot of extra wordage. Let's go ahead and just write it out, rewrite our information, but much simpler. So again, going back with our formula, part over base, which is the same thing as part versus, over total. So part, we actually don't know how many those are. So we're just gonna say X. And our base is gonna be 900 light bulbs. And that is supposed to be equal or equivalent to 2%. All right, so here we're gonna be forming our next step is that we're gonna go ahead and turn this percentage into a fraction or a ratio. That way, all of this can become a proportion. That way, there's two different ratios that are equal to each other. And then we can cross multiply to solve for X. Starting to look a little bit more like algebra. So let's go ahead and simplify this. Or rewrite all of this again. So we have X over 900 is the same as 2 over 100. Simple enough, we know 2% is 2 out of 100. So we're going to go ahead and cross multiply at this point. Cross multiply. And multiply this by this, and this by this. You're always going to multiply the top with the other bottom. So this top's going to go with this bottom, this top's going to go with that bottom. So we cross multiply. Honestly, it doesn't matter if I do this one first and then this one first, but just to make it easier, because we read from left to right in the English language, I'm going to cross multiply whatever has the X first. That way I can write it as 100x is equal to, oops, that doesn't look like an X, that looks like another Greek symbol, is equal to 2 times 900. Again, you can see why I have the X that we're solving for as a curly X instead of looking just like our multiplication symbol. So here, by having multiplied the X first, or at least written it out first, I can read out 100x is equal to 2 times 900 instead of having to write this part first and then this part next. Just makes it a lot easier to have our unknown on the left side. So how do we isolate the X? We're going to undo what's being done to it. It's being multiplied by 100 here. Let's go ahead and divide by the same thing. Divide by 100 on both sides. So we know that X is the same thing as, let me go ahead and simplify this. 2 times 900 is 1800, divide all by 100. Hey, don't we remember that what we had just covered, whenever you divide by 100, you actually end up moving the decimal point 2 times to the left because there's 2 zeros. Let me do this. So really, it's just equal to 18. We can expect 18 defective light bulbs out of a total of 900 light bulbs to be manufactured. 18 light bulbs out of 900 isn't too bad. A 2% error rate, as what we're seeing here, is not so bad. Now, if it was a much larger number, it could cause problems for the company. They might be losing more money. However, when you're seeing bigger manufacturing industries, or even like with our internet, our service providers, if we have like an error rate of like 1%, it might be more acceptable for different uses. Like 1% error use when you're like web browsing, not an issue. But like if like Amazon and they had a 1% error rate, like whenever you're trying to like log in and do shopping, they would lose lots of money because there's like probably millions of transactions. In that case, you want to make the error rate super tiny, like 0.0009% error. That way there's less total errors. Any questions so far? Okay, I'll go ahead and move on. Let me actually write it out. So 18 defective light bulbs. Something else I want you to take note with word problems is that here I specified that they were made yesterday. And the word problem might give you different numbers. They might say, well, there was 900 light bulbs made Monday, and then there was 400 made Tuesday, and then 800 made on Wednesday. But then the question's probably going to ask of either like Monday, Tuesday, or Wednesday, or ask for the total of defective light bulbs from those 3 days. So you need to be able to identify which is the part I'm going to be dealing with and what is the base I'm also dealing with. And if you have to deal with a two-step problem where you have to add multiple days of defective light bulbs, you also need to go ahead and identify that. I'm going to go ahead and erase. Alright, so we've talked about percentage. Let's go ahead and talk about the percentage formula. It's pretty much what we were already doing, solving for different things, but let me go ahead and just explain it in a different way. That way you can just like click or submit. If you already understand it and you see that the method I'm going to be showing right now on this board is a little confusing, don't sweat it. Whatever way that you learn it is just the way that you're going to have to, that you can stick to. And also, for the exam, you can get to the same solution using both methods. It doesn't matter, and most of the time they're not going to ask you to even show your work, if at all. So let's say that we're talking about the part. Our formula really is part is equal to our base times our rate. Some people really like formulas, so we're just going to go ahead and just follow this through. Part, the same thing if I go ahead and okay, you might recognize something very similar to this graphic is in your science class when you have that little triangle. Let's break it down. We know that if you want to solve for part, we have to multiply the base times the rate. Or let's say I want to solve for the base. I'm going to divide part by rate. Or it's seen like this. Let's say I want to get just the rate. Right. So I'm going to look at the rest of these graphs and see, well, rate is the same thing as part over base. So what can we see that these three formulas have in common? I will never, ever, ever, ever divide by part. I might divide by rate or base, or even multiply base and rate together, but never, ever, ever will I divide by part. If this helped you, this is great. Just remember part, base, rate. But I know that all of these are 4-letter words that rate, art, and then base. It might just sound very jumbled together. You don't have to worry about this then. If you just know it conceptually like we were doing previously, you don't need to like memorize any formulas at all. Any questions on this graphic? Okay. We're going to go ahead and use this little graphic right here for a problem. Let's see how practical it is. Some people really love this method because they can just like plug in and just get their answer straight away. So we have part and then base and rate. Let's say we have a laptop is $1,600. For a back to school special. There might even be like Labor Day sale or President's Day sales that you see. It's a back to school special. Usually it means that something's going to be discounted. So something is going to be cheaper than the original price. Although I've been to stores where they were selling like ski items and there was like a clearance rack and it had the original price of like a few $100s and then the clearance was just 20 cents off. That's why you always want to find out your percentage to find out if you're really getting a good deal or not. Okay, so for a back to school special, the manager reduced the price by $640. So I'm just going to warn you right off the bat that this is going to be a 2-step problem because they're not telling us what was the total. The base was $1,600, but they're not telling us of a part of the discount. In fact, we need to calculate our part by using how much they reduced it from the base. So let me go ahead and start filling in right here. I'm just going to write it like this. Okay. So we have the base is 1,600. Our rate. Oh, I'm so sorry. I forgot to ask the question. Question is, what is the discount in percent? So our unknown that we don't know, we want to find out, is our percentage. So in this case, we don't know yet our rate. Remember, we can always convert this. It's the same thing if you just go ahead and add a little percent sign at the end. So we don't know what that is. Our part, though, is how much they discounted. So it would actually be this much. So let me go ahead and rewrite this. So this would be the total amount that they pay for it. How much you would be paying for it without the special, like the original price. But then to find out the new price after the discount, we will get the price of the item. We know how much it's being discounted. So now we'll know what is the new price of the item. So we can go ahead and simplify this. Into, let me just go ahead and double check my math for my notes. Okay. And always remember, you're welcome to use a calculator if you wish. If you can use it on the exam, no problem in using it. You'd rather not get bogged down on having to write things down, we can just go ahead and just type it in. So if we go ahead and type in 1600 minus 640, we get $960. So that's the new price, $960. All over our base of 1600. That is going to equal our rate. Right here, we're at unknown because we know following this formula, if we're looking for our rate, parts is going to be divided by base. Going ahead and doing that. Rate doesn't necessarily deal with money. Also, since we have two different units dividing each other, we go ahead and cancel the dollar sign. And now we're going to divide 960 by 1600. Now, this is some other cool trick that can save you time, is when you're dividing numerator by denominator and there's a zero here, you can go ahead and just line up the zeros and cancel them out. That way, when I rewrite this, I can just say 96 over 160. It's a lot easier to visualize this 96 out of 160 versus 960 over 1600. So if I go ahead and punch that into my calculator, I'm going to end up with 96 over 160. I'm going to end up with 160. In order to get our percentage, I have to move my decimal point 2 times to the right. So I do 60, and then I add the percent sign. The thing with rate is that it can be written as a decimal point, it can be written as a fraction, because if we simplify this, it could still be a fraction, or we can just convert it into a percentage. Any questions on this so far? Okay. So you want to see, okay, is this, not sure if you did your math correctly, seeing that 60%. So $960, does that look like 60% of 1600? Yeah, because 50% or half of 1600 would be $800. So I know for sure that 960 is more than $800. So I can kind of just ballpark it, yeah, I know it's more than, I know it's 60% because 960 is more than 50%. You're like, okay, where did we get the 50% from? It's just kind of like eyeballing, seeing if we did set up our formula correctly. You can say, really, you could divide everything, but want to know 33% or divide by 3 in that case, that's fine, but always dividing something by 2 is much easier, and using that as a benchmark for 50%. You always move, wait, yes, you will always move it 2 times to the right. And it can actually get kind of confusing, like let's say if I did, let's say I ended up with that as my number. I would move it 2 times to the right, always, and that's going to be the same thing as 60.8%. For those of you who have seen like credit cards, they might have like 29.99% interest rate. That's in the next section, but that is an outrageous amount. 30%, if you don't pay your whole bill for that month, you're going to owe 30% extra of that total bill. That is why you got to be very careful when you use credit cards. There can still be a decimal or like points whenever you're using percentages, but always it's going to be moving it twice. From whenever you go from something written as a decimal like this, when it's like 0 point something, you're always going to move it twice to the right in order to get your answer in percent. Any other questions? No? Okay. I know if I say like no, okay, that still means you can go ahead and type out your answer. I'm just giving a little extra time in case. All right. Something else I want to point out is whenever you recognize a problem that's going to be asking about percentages or dealing with parts, want to know like how much was the discount or where do you want to work with. If you're missing more than one item for this triangle, you might not be using this example yet, or there's something else that you need to calculate in the problem. So let me go ahead and erase this. Like here, we didn't have the actual part. We had to like derive that from information in the problem, like 1600 minus 640. Then we had the part. So always like once you're done, like say, okay, did I get my part? Yeah, I found it out by doing this. And the base, yeah, that was already included in the problem. And they were asking for the rate, and that was my unknown that I needed, so I got that. Honestly, you could have also written this as question mark. Could have done the X. That way it feels like more like algebra. And we know that rate right here is also what we're putting as our X. If you want to deal with that. If you don't want to deal with like formulas or anything, just solving for X. That's the beauty of algebra. If you set it up all correctly, you can just plug in your numbers and like distort it as needed. I'll go ahead and erase this. Okay, we're 10 minutes from our 1 hour mark. We have a 10-minute break then left in. Let's see what we got next. All right, I'm going to cover this very small section about how you're going to be punching in this information to a calculator. And then we'll go on a 10-minute break, and I'll talk about simple interest and then the percent of change, or like the rate of change. So this is for your calculator. I do want to point out that if you want to go ahead and so much for that. Let me get rid of that marker. That marker's trash. And write it on the calculator like this. Let's say I'm trying to go ahead and do 0.25 times 100. I punch that into the calculator. My answer is going to be 30. In some calculators, you have an option of also like converting it, like typing in an actual fraction. You can write it as this. Depending on what kind of calculator you have. Even on phones, you can go ahead and do this. And you can multiply it by, I'm sorry, not 100. I meant to write 120. For those of you checking my math, yeah, this is the correct answer. Times 120 is equal to 30. And we know this to be true because we know that 0.25 and 25 over 100 are the same value. Another thing I can do is, in some calculators you don't have the option to write it like this. Let's say you're not using like a fancy TI-84 or TI-85 calculator. The more common way that you might see it is like this. Now it's going to be very important if your calculator has the option to use little parenthesis signs. Because if I don't, knowing our rule of order of operation PIMDAS, which if I go ahead and write over here, and this is just an acronym, parentheses, exponents. We'll be getting to exponents later in the course. Exponents, multiplication, or multiply, divide, add, and subtract. The first thing that we're going to deal with is whatever is inside the parentheses. So then I'll go ahead and the calculator will know, okay, I need to compute this part first, and then I'll add the 120. Because if I'm not very careful with my parentheses, it might try to multiply this. Going to our rule of order, parentheses, exponents, multiply, it's going to try to multiply the 100 and the 120 if it wasn't for this parentheses. And then we're going to get like some other weird answer. If we did that, we'd actually get something like this, which is totally not equal to 30 and definitely not the same as writing it as one of these methods. Let me go ahead and erase this. Let's say that you're using your simple little 4-function calculator that is super tiny. You're going to have to do it in 2 different steps like this. And you might get like a 0.25. Sometimes you get the option of doing like the answer, like the previous answer that you calculated, and then multiply that by 120. Then you get 30. And you might ask me, well, I already used 0.25 up here. Like, what was the whole point of writing it out like this? Let's say you don't want to go ahead and use like precious brain power. And like, oh yeah, 25 over 100 is the same as like 0.25. You can just go ahead and like, let's say you had like a ratio or a fraction already set up. You can just directly just plug it in like that. That is something that you want to keep in mind whenever you're dealing with calculators. Although I will mention, if you know like 1 plus 1, you don't need to use a calculator to add that up if you don't need to. You can go ahead and use some mental math if you're comfortable with it, but if you're like struggling, like, oh, carry the 4 and like trying to use your fingers, you can go ahead and just use a calculator. It might just be a little faster and less likely for you to have error. Any questions on this or any questions on PEMDAS? Like the order of operations, and operations really mean like the little symbols that we use in math, such as like the little parentheses. You can also use brackets or the little curly marks if you've seen them. Exponents is like, let's say I have a number right here, like a little number, like a little superscript. By superscript, I mean it's like a little super here, it's like up top. If we multiply, if we divide, if we add, or we subtract, these are our order of operations. So they're going to go in this order, from parentheses to exponents to multiplication, division, addition, or subtraction. Okay. there's no questions, we can go ahead and go on our 10-minute break. Go ahead and put a little timer, and that will let us know when it starts to beep. We know that we're going to go back to lecture. And multiply, erase this. All right. Timer. All right, got it. See you all in a few minutes. All right, so 10 minutes have passed. All right, something else I do want to point out is, let's say you're shopping and you want to buy some granola bar. Let me erase this first. So you go to the store and you want to buy some granola bars. And you see on the nutrition label, you see right here the total fat. It's going to give you two different values. It's going to say 2.5 grams. And then right here, it's going to say 3%. There's a little top right here. Let me get a little bit closer. You're going to see something that says percentage of daily value. So even though it's 2.5 grams, it is 3% of your daily value. Now there's a little asterisk which tells you read more on the bottom. So I go up. So the percent daily value tells you how much a nutrient and a serving food contributes to a daily diet of 2,000 calories a day, which is used for general nutrition advice. So typically, so we're saying that this is a percent of daily value. Like, what is the recommended amount of calories you should take per day? So they actually give us all of our information. We know that our rate, 3%, is 2.5 grams. I'm sorry. Out of check the math here. Saying that we got 2,000 calories. So then we actually get like a certain number of calories. This is abbreviation for calories. So I know this is 2.5 grams. But let's say business is being very sneaky. They might actually say, you know what? We're not going to say 2,000 is a daily recommended value. They might change it to this much. Now, where they're using their base as a bigger number. So when I'm increasing my base over here by a bigger number, and let's say that they're claiming to also be like 3%, like 3% of this granola bar is fat. This 3% and this 2% of like 2 bars would be identical. It's still like 3% of the total amount of the bar. But the total amount of like calories that's coming from that is much higher. So like, let's say I saw for X here, X is going to be, so let me not skip steps since we're all learning right now. So we know that 3%, we want to go ahead and convert this into a decimal, or let's say you want to say 3% is the same as 3 over 100. Say X over 2,000. Make that look like a 2. Okay. Cross multiply. You get 100x is equal to 3 times 2,000. Divide by 100 on both sides. Knowing our trick where if you have a numerator and a denominator with zeros, just go ahead and cancel out those zeros. You know what? I could even turn this into mental math at this point. You got x right here, curly x. That is not the curly x. See, this is the issue why you want to go ahead and label your multiplication sign different from your symbol. So we have x is the same thing as 3 times 20, and I got rid of the 0, so I just have over 1. Practically didn't even have to write over 1, because anything divided by 1 is whatever value that was. So you can just have it as 3 times 20. Oh, x is equal to 60. So we're saying that's 60 calories in this bar. So let me show a graphic. In my granola bar, I'm talking about the granola bar, not bar as a place that sells alcohol. So this is bar B. So here, I know the denominator right here is different. My numerator is going to have to be different as well, even though they're both 3%. So just for the sake of argument, let's go ahead and solve for x for this other bar. So we'll go ahead and set up our proportion. Cross multiply on both sides, so I get 100x is equal to 3 times 2,500, divide both sides by 100. I get x is equal to, oh, well, look at that. I can simplify this even further. Got rid of those zeros. Now it's just, and I know that dividing over 1 is the exact same thing, so I just get 3 times 25. So x is equal to 75. Whoa. Okay. So how many calories from fat, because we're talking about fat here, is coming from this bar? We'd be getting 60 calories from fat. But let's say that they're devious, and in the fine print they change the recommended daily value, and this is much more common in with certain protein shakes where they can get away with it, where they might argue that someone needs more calories than if they're a bodybuilder. And if there's movement or sound that you hear, those are my dogs. They heard me talking about food and they got very excited. Let me just fix the camera. Okay. We're seeing that these two different bars, even though they both claim to be 3% fat, this one is going to have more fat than this bar. You might even get a question that says, between these two bars, that both of them claim to have 3% fat, bar B has how many more calories from fat than this other bar? Well, I calculated how many calories from fat is on both bars, and then I find a difference. I subtract. So I see that there's a 15 calorie difference. That would be an example of a two-step problem. Again, two-step problems are a significant chunk, let's say 25% of your questions, but if you got them, great. If not, don't worry. There's still time to cover everything before we go into these, until we have the high sit exam, which, by the way, I'll have to be the one that clears you for it. Any questions on this? If you're not comfortable with reading your nutrition facts, we're going to be going over that more in the science class, when we use combine math with science for decision making. But if you're not, it's okay. We're just keeping the labels of total fat percentages all together. There's no need to feel intimidated. We're not going through everything yet. We're just using this as a real life example. If you're out to get a mass gainer and gain gain muscle mass, the same principle that you use to find out like, okay, which one of these has more protein. So same thing, like we find out, let's say we weren't talking about calories, let's say we were talking about instead like daily value, like 3% of this bar is protein, we would say that the bar B actually would have more protein if our label here was protein instead of calories. I'm gonna go ahead and erase. Okay. A much simpler way to understand it is if I say 3% of this cup, like pour me a glass fill this cup with 3% water, versus if I get my gallon right here that I use for water, if I say 3%, our container, our base, are two different sizes. But so if we're trying to get the same percentage, like 3% here and 3% in here, they're actually going to have different volumes inside of it. When are they going to open the testing center? So they are in the process of opening the testing center pretty soon. The minute that it's open, I'll let you know. But in order to test you, first we gotta finish at least the majority of the course, and then when I like give you an evaluation to see like if you're ready to take the exam, then you can take the test. Also, if when they open the testing center, they might limit it to like a smaller amount of people to be inside for the sake of social distancing. Also, might have missed taking their tests because we have different like courses coming in from high set. Like if you have already been like cleared for like your reading and writing from your previous class, you're gonna get priority in taking that exam first versus like when you finally get cleared for your math or science, because that happened later. We want to test you first on like what you already cleared by first. That way, like that way you don't get rusty. And there's also people are gonna get first come first serve depending if they've already been cleared. So let's say you get cleared to take the exam, you're gonna get first pick to take it as soon as possible versus someone who hasn't even been cleared yet. Okay, so STC has made an announcement that like all of its classes, all of its academic side classes are going to be online for the summer. However, that doesn't necessarily mean continuing education, which is like the ones that do like the ESL classes, certain technical training classes, and our high set GED classes. If we are when we return to class, they're gonna limit the number of students per class. If I recall from the email, it was like 9 students in the classroom, and they might have to split like the classroom into like the students into 2 separate classrooms and have the teacher go like from like one classroom to another. So if you take classes and we're able to actually take classes in person, it actually might be where like let's say we have like 15 students. They were suggesting that I have like half of the students here. So let's say I have like 9 students here in one classroom. And then in another classroom right here, that's a little door symbol. And then here I have the rest of the students. So let's say I have 6 students. So since these classes are normally like 2 hours, you would expect, or what they're suggesting is for me to be here, like lecturing to these 9 students, and maybe have like a projector right here. I like have like a little camera right here. Camera symbol. What does it look like? Camera symbol looks like this. So there would be someone filming me, or like what I'm using now. I'm using a camera right now to live stream to you guys. and ladies, and it would just be live streamed into another classroom. And they were suggesting that I would be like 1 hour here, and then I switch, and 1 hour, like the next hour, like go back and forth. Or they were suggesting like that way people take different turns at having me in person, because even though you have this chat box to ask me questions, it's quite not the same as like raising your hand and like being able to like more casually interrupt, like, oh miss, like what is that, like a, is that a time symbol, or is that like a little curly X? It's much more natural for the in class for a lot of people. So this is what they're suggesting right now. I haven't heard of any new updates that they're coming up with, but right now, if the class is really small, like if it's less than 9 students, and that way we can like meet local county and city ordinances. I think right now they're limiting gatherings of less than 10 gatherings to be 10 people or less. Then like 9 students plus 1 teacher, that would be like 10 people. I wouldn't have to be filming or anything. We'd just be all together in the same class, and if this was a class layout, like I'm up here where the board is, like talking, and like there's different like little. Let's say that these are the different tables where you can sit. They just might ask for people to be like sitting separate from each other. This one here. This one. That way, like all of you are like scattered together. There's one more. Yes, I do. I also agree. The same thing. However, this is how we're making do. And let's say that we can move to like in person, like in the middle of the class. We'll go ahead and do that, because it is a lot easier for the student, especially with concepts that are more interactive, like math and science. So we're gonna move on. And I really like having like recordings that you can go ahead and look back on, or if I make a mistake, you can like go back and catch it instead of having me remember something that I did wrong. Human error. If we go back to in person, I'll probably keep on filming if that's okay, and then upload those that we can go ahead and review, because I know for a lot of students, especially with math, if they're copying down, they're kind of like copying, and they might not focus on actually what I'm saying. So if with a video you have the option of like reviewing yet again. Yes, on the Microsoft Teams I had like put it up, but since not everyone has access to the Microsoft Teams, thank you for pointing it out. I'll go ahead and email everyone the exam that I'm going to require you to take. It's a practice exam made by the actual manufacturer of the test, the HiSET exam. They have like a little practice test you can take, and once you reach a score of 80%, so you can take this exam, like you can get like a 50% on the first time, keep on taking it, and then once you get like an 80%, it gives you the option of emailing the results to someone. Go ahead and email the results to me, or you can take like a picture or a screenshot and let me know that you received above an 80. That way I can go ahead and just clear you for the exam. And you don't have to wait to take the exam until the very end of the class. You can take the practice exam to see like where you lie. That way say, hey miss, like I really mastered ratios and proportions, but I'm like really shaky like on my geometry. That will help you review, and that way you can let me know like this is where I'm having trouble with. You won't know what you have trouble with if you don't know what it is. So I'll go ahead and email you that after the class ends. Now we're going to talk about simple interest. So, interest. And I don't mean like interest like, man, I'm really interested in like having pizza tonight. Yeah, I'm talking about interest as in a fee paid for using someone else's money. So let's say that your friend says like, hey, like, can I borrow like $20? When you lend someone those $20, you run the risk of them not giving it back to you. And also, you won't really benefit if you give them the $20 and then they give you exactly $20 back. Here. So let's say you lend the $20 to this person, and then so you lend it, and then they pay back the $20. Well, you took on a risk of losing $20 if they didn't pay it back. So what some people do is they want to make their money work for them, and they're like, yeah, you can pay me back, but with a 5% interest. And there's also, you can do just like overall interest or interest per time period. So like with most credit cards, the interest rate's gonna be like this. And this is per month. So like every month that you don't pay money, they're gonna charge you a fee, and it's gonna keep on increasing every month, not just the total value like forever in your lifetime. So that's a way that banks are able to make money off of their interest. And also, if you lend some money out to someone else or you invest in a company, you can get interest back. Oh, that's a dog. So another word that you might see, especially when you like apply for loans or like home loans, you might see a word called the principal. So the principal is the original amount so let's say I lend someone $20. That is my principal. And then my interest would be like if I charge them like 5% as an interest rate. Another way that you might hear this is like in a mortgage, like where you, let's say you buy a house for like this much money. And that would be your principal, but then there's like an interest rate on like your mortgage, the house loan for the house, and then that would be your interest. Some people, depending on like what strategy they have, they might pay off more. They try to focus on the interest. People actually try to focus on the principal, because your principal times your interest ends up. And this is where some like new homeowners or people who aren't familiar with this terminology might get in trouble, because they might not include their interest, like how much interest is going to affect your payment. Same thing with credit cards. Let's say like my monthly payments like supposed to be like $50 in order to pay off like a certain amount of debt I have on my credit cards, but my interest is going to raise my monthly my minimum required monthly payment. So we're going to go into like try to get very comfortable with this, because this is where math is incredibly important whenever we deal with our money. So some other terminology I want to include is, let me erase this example right here. Is simple interest. And interest and simple interest are kind of different, and let me show you why. Because simple interest is going to be your interest multiplied by your, is a type of interest where it's your principal multiplied by your rate, like 5% rate, like interest rate. Very different when I'm saying like what is the interest versus the interest rate. Let's say my interest rate is 5%, but of that 5% interest rate, my actual interest is like $200 that I owe. Very different. And also time based. Like if you have like a monthly payment for a car or a home or even a boat. I've seen where people actually buy like bicycles that are like $2,000, $18,000. I saw a bike that was like $36,000. Yes, you heard me right. $36,000, almost the same amount as a car. Where they will also have like different like payment schedules set up for bicycles. I'm not talking about motorcycles, bicycles. This becomes like your foundation for finding out how much do I owe. So this formula could be actually remembered in a much more easier way. So let me erase what's in the black. So let's simplify this. We're using like a lot of like words. Let's just use some variables. And variables just means I'm using like a little placeholder. Like how we use our unknown, we use that curly X to that's a variable. So I can write it down as I, or simple interest, is P, our principal, multiplied by our rate, multiplied by time. I print. Interest is equal to principal times rate times time. So I can write this like this. Now that we have our bases, let's look at an example and then we'll just plug in everything. So let's say Jake borrows $2,500 from his dad. For 3 years, at 6% simple interest. Now here, it's simple interest, not interest rate. Very, very important. How much interest? So like, how much interest will he pay on the loan? So it's not asking like how much he's gonna owe. Like he's gonna owe like the $2,500 plus the interest. We're not asking for the total amount. We're just asking what is the interest he's gonna have to owe besides giving back the original $2,500 back. Let's do this. So if we substitute, you can see that 6%, our simple interest, which is I, is equal to PRT, our principal, which is the original amount that we started with, is $2,500. I'm just going to go ahead and write it down in parentheses, because when you have two parentheses next to each other, it just means multiplication. It's much easier for substitution. We see the rate. So what would be the rate? So we're going to rewrite that as our decimal. So 6%. You want to go to decimal. What do? we know that the decimal place is right here. We're going to move it 2 times to the left. So it will then become 6% will become 0.06. Or the same thing as saying like 0.06. Same thing, I can have a little 0 in front of the decimal place. Just be very careful and be consistent when you're doing your math. So I will go ahead and substitute the rate over here. Okay, and then the time, we're saying it's 3 years. Oh, I'm so sorry. I did something wrong here according to my notes. Rate is a decimal. Okay. Our interest is our unknown. We don't know what I is equal to. We know what the rate is. Sorry if that confused you. That even I have to keep track of, like, I is our simple interest. I mean, our interest. So we don't know what I is. What is the total amount they're going to owe? Just on interest. And this is what really like hurts a lot of people, is that they're able to pay back like the original amount, but the interest, like the high interest rate, like this is like a crazy number. It's really gonna hurt you, and you're just gonna be paying interest and interest like forever and ever. That's why it's better just to like pay as much as you can as soon as possible. So we're gonna go ahead and simplify this. So if we plug all this into a calculator, we're gonna get the value of $450. Well, that's just interest. Like on interest they own. So this one is supposed to be the rate. Yeah, your interest, how much you owe, main is like monetary value. This one is like percent, which was our 6%, but we just to make it easier for multiplication, we turned into 0.06. So just on interest, we're gonna owe Jake is gonna owe his dad $450. But what's the total amount he owes? Is gonna be the principal plus the interest. Now, this is also a very good way. We know that total amount owed is gonna be in dollar signs. We know the principal is gonna be. So whatever we have here, dollar signs, is gonna have to be 2 different dollar signs added. This, I cannot, let's say I wasn't so sure what I was doing, and let's say I try to do this. This isn't gonna work because this is a rate. This is not talking about money. We need dollar signs. And since we did the math over here correctly, it would be this. So Jake would owe his dad a total of, oops. This is how much he's going to owe his dad. So this would be a 2-step problem if it's asking about the total amount owed, because I have to do first calculate what is the interest and then add it on to the principal. Questions? Okay. Excuse me. Let's say that you want to go apply for a loan at a bank, or even on your credit card statement, or even on your mortgage statement. It might give you calculations, like it says, if it takes you 4 years to pay this loan, this is how much you're going to owe on interest, and this is how much you will be expected to pay if you're able to pay it off like in 3 years. Or let's say that you wait on, if you notice like on the credit card statements, it says like if you wait like 10, 15, or 20 years to pay it off, it's gonna be like much more than it owes. Like I've seen like where like it like is multiplied by 5. So if you wait longer to pay it off, you're gonna end up paying more money in the long run, like a dramatic amount. So if there's nothing else that you apply into your life from this math class, please, 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 please pay whatever you owe. Pay as much as you can, as soon as you can. That way, the interest doesn't kill you. Something else I want to point out is the interest rate here. I forgot to mention is an annual interest rate. That's talking about every year. Here we're talking about 3 years. Okay, so like for every year, we're going to give an interest rate of 6%. If it was talking about how much we owe in 3 years, if it was like per month in monthly interest rate, you might get bamboozled. Normally on credit cards and normally like with loans, they call it annual interest rate. Like the 24.99, that is typically a annual interest rate. But please read the fine print. Someone who's an accountant might be typing out a loan or something and accidentally type in per month instead of annual, or it could be something very sneaky. You'd want to take into account like, look, this is per year, not per month, because let's say that this was per month, just for the sake of argument, I have to multiply by 12 in order to calculate how many months there are per year. So please read the fine print. I know a lot of us in this day and age of like reading terms and conditions, or even for like accountants and bankers say like, oh, don't read it, I already explained it, you can just sign. Please don't. They could be mistakes and you're the one that has to deal with it, not them. It's your name and your money on the line. Okay. What else did we talk about here? Okay, so with simple interest, we did an example on owing money. We can do an example with savings accounts. But you know what? I'll go ahead and turn that into a homework assignment. Let's savings account. So, your homework. Look online for a bank that offers a savings account. Don't sign up for a savings account. You don't have to. Like, that's not part of the assignment. I just want you to like kind of like get familiar with it, with a savings account. Look at the interest rate. So let's say I go to a bank and I get a savings account and I put $100 in my savings. I remember I used to have a savings account where like they used to give me like 1% interest. Like I get a little bit extra money, like where the bank says, "Thank you for giving us money to work with. We're gonna give you back like whatever percentage you have in savings as like a thank you." This is where you want money. Like this is where interest is. That's like when interest is owed to you. But I've also been I ended up closing that savings account because they gave me very little money. I went someplace that gave me 2.5% interest instead. So the higher the percentage, I was getting more money in return for having my money in the savings account. So just for your homework, I'd like for you to look up just any random bank and find one that has a interest rate of a savings account that is more than 1%. And I'm just gonna want to know what the name of that bank is. And when I ask tomorrow, we'll go ahead and put that in the chat box to see what are some banks where, knowing the math, we could say, well, if I was gonna open up a savings account, these would be among the different types of banks I want to put my money in the savings because I'll get more money in return. And the reason this works, why the bank in the first place is going to want to give you money, is because the banks, they invest in a lot of different things and even in operations. So technically, with a savings account, the bank is borrowing money from you. Isn't that pretty cool? But you might think it's pretty unfair, like the interest rate that you're getting compared to what they might charge, like a 24.99. It's how it is. Just try to make it even out the odds by getting a higher interest rate back. You want high interest rate for money that's coming to you, but when you owe money, you want a low interest rate. So that's your homework for tonight, and I'll go ahead and email you the practice tests. If there's any other questions, I'll stay online. Other than that, good night. So I'm just writing what's going to be on for tomorrow. At this point, you can already exit the live stream. I'm just putting on the title for tomorrow. And we can do review. Alright, so tomorrow our last topic is going to be percent of change, and then we'll go over a mini review. And after tomorrow's mini review, I'm going to give you any questions that you want, any more type of questions that you want to take as homework for your grade. And after that, we'll be getting into statistics, like probability, data, like how to read different like kind of charts and how to read labels. So a lot of this is going to be very visual based. Okay, since we are now past the 8 o'clock mark, I'll go ahead and finish the live stream. See you all tomorrow. Bye.